Hi friends, in this problem we are given x, y, z are in harmonic progression. Then we have to show log of x plus z plus log of x plus z minus 2y equals 2 into log of x minus z. Let us first try to create a relation between x, y, z and then we can bring logs between them. Right? If x, y, z are in harmonic progression, what does that mean? Y is the harmonic mean of x and z. What does that mean? That automatically means y equals 2xz by x plus y. Very basic formula, right? Y should be equal to 2xz by x plus y, right? If these three are in harmonic progression, automatic means 1 by x, 1 by y, 1 by z are in arithmetic progression. We can clearly say y equals 2xz by x plus y, right? This is the regular formula. Now let's take this expression log of x plus z plus log of x plus z minus 2y. Let's take this y equals 2xz by x plus y and substitute it here. Right, replace this y with 2xz by, sorry, there's a typo here. This should be, z. 2xz by x plus z, not y. Right. So then this becomes log of x plus z plus log of x plus z minus 2y. That is 2 into 2xz by x plus z. Right. Then let's look at this part. This part becomes x plus z whole square minus 2 times 2xz, which is 4xz. Log of x plus z whole square minus 4xz by x plus z. This one, let it be as is, log of x plus z. What will this become? X plus z whole square minus 4xz. This becomes x minus z whole square, right, by x plus z. So this becomes log of x minus z whole square by x plus z, right? Log a plus log b. We can take a single log and multiply this one and this one, right? This one log a plus log b becomes log of this into this. X plus z and x plus z will get cancelled, right? Then it becomes log of x minus z whole square, which is equal to 2 log x minus z. That is given, that is the right hand side. Right? It's a very, very simple problem. Only thing that we should know is the harmonic mean is 2xz by x plus z, and just substitute that harmonic mean here and applying basic logarithms, we can prove that this left hand side is equal to right hand side. Very, very simple problem, guys. Right. Thank you.